Welcome to Dear SQL DBA, a podcast and YouTube show for SQL Server database developers and administrators. I'm Kendra Little. Today's episode, we're going to talk about, is it bad statistics in SQL Server that are slowing down your queries, and steps that you can take to check out your queries and see, is the issue bad stats? But before we get to the episode, there's some pretty cool things to talk about this week. The coming release, which up till now has just been known as vNext for SQL Server, with a little v and a capital N, sort of stylishly little v setting off vNext. It now officially has a name. It's SQL Server 2017. And looking at the calendar, hey, that means we are going to be seeing this thing soon with real RTM bits. Very, very exciting to have that announcement come out today. And other cool stuff, Microsoft has put out more information about cool features that they're working on, things that are really exciting and that are going to change the way that we work with SQL Server. In a past episode, I speculated a lot about a new feature that's coming that's called adaptive query processing. And I really was just looking at a few public bullet points when this was being sketched out in the early days. Well, one really cool thing, as of today, there is now a video out by Joe Sack, who's a program manager at Microsoft, and he talks through and demonstrates in a video really cool things that you can see in this adaptive query processing family. You can see things about interleaved execution, batch mode memory grant feedback, and then batch mode adaptive joins. It's a great video. It's out on YouTube, really easy to watch. And what I did is I took my old, I have my blog post that I did for the episode I had on adaptive query processing. I went ahead and embedded that video at the top of the post, and I put a little note on it like, I don't want to take any credit for this video, but like, if you are looking at this post, what you really want to know is not my speculation from the early days. What you really want to do is go watch this video, give it a like on YouTube, give it a thumbs up. It's on the Microsoft Cloud Platform's YouTube channel. So if you search for adaptive query processing SQL Server, you're going to go ahead and find it either by my blog post or by getting straight there. But fantastic, interesting video. So if you like Dear SQL DBA, I think you would like that video too. So let's get to this week's question. And I'm paraphrasing a little bit because this is actually part 2. Last week on the previous episode, we talked about, could a change I made in my index maintenance be causing queries to be slow the next day? And one of the things I hypothesized in that episode was the change to index maintenance, one of the side effects would be that before, when they were rebuilding all their indexes, a side effect was they were updating all the statistics associated with those indexes. When they went to a more selective index maintenance process that sometimes skipped indexes and sometimes reorganized them, the statistics associated with the indexes that got skipped or reorganized weren't getting updated as part of the job. So one of the things I hypothesized was it could be that some of your queries are getting slower because they're no longer getting the statistics updated associated with those indexes if they're getting skipped or hitting reorganize. And I did suggest you can get a maintenance script, and there's cool free ones out there that integrate statistics updates, right? You don't have to have this problem, but this week I want to talk about, so if I suspect that my queries are slow because of out-of-date statistics, and maybe this is due to maintenance, maybe it's not, right? Maybe, I have statistics maintenance, but I suspect my queries are slow and I suspect it's a stats issue. How do I look at my queries and tell, is that the problem or not? So we're going to look at this in SQL Server. I've got demo code that I'm going to put up in a gist on GitHub, and I'll link to it on the blog post for this episode and in the podcast notes and everywhere on the YouTube episode. But if you are listening to the podcast, I'm totally going to talk you through this. You can go back and watch the demo if you want, but you will hear what you need to know about how to follow this process. So let's go on and dive on in and step through looking at some stats. I am running my demo today on SQL Server 2016. And I'm doing that because SQL Server 2016 Developer Edition is free to download. It's latest and greatest, and it's really convenient. But to show this stats problem, the setup steps that I've already run actually did a couple things to say, okay, I don't want to use all the cool new features. What I did was I said, I'm going to use the legacy cardinality estimator. The new cardinality estimator is actually smarter about some things about statistics, and I want to show the older, not as smart version when I'm talking about the problems. I also lowered my database compatibility level because I wanted to go back to the old threshold where SQL Server will only automatically update statistics for tables with a significant amount of rows when approximately 20% of the rows have changes in them for the columns involved in the stats. So I went back and kind of lowered some things down, but I'm still on 2016. So the first thing I'm going to do is create a simple procedure. It's called invoices by last edited when. And this procedure is using the free Wide World Importers database from Microsoft. And it says, I want all the rows from the sales.invoices table, and it joins to sales.invoice lines. But I want all the rows where the last edited when column is greater than or equal to cutoff date. And cutoff date is a parameter for the stored procedure that's passed in. So I say I want to execute invoices by last edited when, and then I give it a cutoff date, which is a date time to column with precision 7. So I run the stored procedure for the first time, and let's say this is run by someone in our customer service department. It happens to be run for the cutoff date of January 1st, 2017. My setup script has messed around in the rows with this table a little bit. That first run puts the stored procedure's execution plan into cache. And that it compiles a plan, figures out how it wants to run it, and stores it in memory. I don't have any weird hints in this query or stored procedure or anything. So SQL Server is going to, when it's run for other dates, go ahead and reuse that initial execution plan that was put into cache. So it sniffs, the first time it runs, it sniffs the parameter value that I give it, and it says, hey, for the cutoff date that you gave me the first time I ran, I'm going to optimize a plan, and then for future runs, I'm just going to reuse that plan until I have a good reason not to. So if we do get to a point where statistics update because we get past the threshold it's using to say, oh, we've had a significant amount of churn, or if maybe SQL Server restarts, I would get a fresh plan. Or if we have memory pressure and my plan is aged out of cache, the next time it's run, I might get a new plan. Or if somebody changes some of the SP configure options in SQL Server, that might cause me to get a new plan, the next time the stored procedures run. But for right now, like none of those things have happened. It's just the stored procedures run again and it reuses the plan. So this has all been going on in the background. People have been using this, and really I've only run this 4 times, but we'll pretend it's more. And I'm told, hey, this query is slow. You know, this page that we're loading that runs the invoices by last edited when query, it's running really slow. One of the things that I can do with access to the SQL Server is get the execution plan for the slow query from the query cache, because I want to know, okay, you're saying that this is slow. What is the execution plan that you're using? We can do this by querying dynamic management views like sys.dmExec query stats. If we look at the query stats DMV and join to several other dynamic management views, like one for the SQL text and one for the query plan, I can actually say I would like to see information about how many executions have happened and how many logical reads, or even when the time was that this was compiled, as well as the query plan for queries whose text is like this value. Now, since I'm looking at a stored procedure, I could actually use a view called sys.dmExec procedure stats and just give it the stored procedure name. But I like to do demos sometimes with sys.dmExec query stats just because not everyone uses stored procedures. So looking for some of the text inside the query can be a useful thing if you don't always use stored procedures, and sometimes you have to troubleshoot parameterized queries or just plain ad hoc queries that aren't part of stored procedures. So I've just said, hey, I want to look at the stats in the plan for a query whose text is like, and then I just grabbed a little bit of the text of the query that we're looking for. Sure enough, we find the execution plan is in cache. It has an execution count of 4, and I can see things like the total worker time, which is the CPU time. I can see logical reads, and I've just put a few columns in here. And I have the query plan from that sys.dmExec query plan DMV. So if I click that and open it up, what I can see is a map of how SQL Server optimized this query. One of the things that I want to do first is save off this execution plan. And I break this out as a separate step because I could not tell you how many times I have forgotten to save off the plan, and then much later, I can't find the plan in cache anymore because something's happened to cause a recompile, and I wish I had saved off that slow plan. So when you have an execution plan open, you can right click and say save execution plan as, and make sure to save it off. I'm going to save it as the plan I don't want to forget. And I probably have used an illegal character in the file name. That's my style. But I've saved it as a .sql plan file, and I can reopen that plan later. Another thing that I want to do while I'm looking at the plan is to get some important information about how it was compiled. While I have the graphical plan open, I open the properties window and click on for the query. In this case, the stored procedure really just has one query in it. There's a set statement above the query, but there's really one query. And what I want to know is, when it ran this query, what values did it compile the parameters for? With the select operator from the query highlighted, I can look in the properties window and find there is a parameter list. And I just have one parameter. It's cutoff date. If I had multiple, I could look at them, and I can actually see in here when it compiled this execution plan, what was the value it compiled cutoff date for. And I can see that the time that this ran and actually generated the execution plan, it was for January 1st, 2017. That's a really, really valuable piece of information because I may get different plans when I pass in different values. And if I'm asking, are my statistics accurate? What I really want to know is, when I'm looking at an execution plan, I don't want to know, are the row estimates accurate for any value of parameters that are passed in? What I want to know is, are the row estimates valid for the set of parameters that this was compiled for? So in my case, I'm asking, are the row estimates reasonable for a cutoff date of January 1st, 2017? And knowing that value is really important when judging, do I have good statistics or bad statistics? One of the reasons I also like to save off the execution plan is it saves off the properties along with the plan. So I can actually not only see what plan I had, but what the compiled for values were as well. This plan that's in cache in SQL Server is what's called an estimated plan, or at least it's what's called the cached plan. The terminology around here gets a little weird, but one of the important things to know is it is not what's called an actual plan. What's called an actual plan in SQL Server contains a lot of estimates, but also contains information like how many rows did I actually get back. In these cache plans in SQL Server, I don't have that how many rows actually flowed through the different operator information. That's totally fair because every time it runs, I may have different amounts of rows flowing through those operators. This just has how many rows were estimated would flow through the operators when it was compiled for that initial set of values. So what I can do is I can do things like click on different operators in the plan. And in my case, I've clicked on the clustered index scan on the top right. And if I look at the properties of that clustered index scan, there is what's called a predicate on it. And I'm looking in the properties and I can see, oh, on this clustered index scan, it had to scan the entire clustered index of the sales.invoices table. And what it was looking for in this predicate is when is last edited when greater than or equal to the cutoff date. So this is where it's finding the rows that are greater than or equal to the parameter I'm passing in. So knowing, okay, how many rows did you estimate will come back is pretty important there. Hovering over the little line coming out of that operator, I can see that it thought it would find just one row past the cutoff date for that. Looking at the plan by itself, I don't have an actual row count there. I can see, okay, you estimated that you would get one row after the cutoff date. And I know that the cutoff date passed in was January 1st, 2017. If I know my data set, I might say, oh, well, wait a second. It's already tax time. It's already April. I'm gonna have, if I haven't had more than one row in the invoices table, we haven't invoiced anyone since January, right? So logic may give you a mental estimate, but we don't actually yet have any evidence of, okay, how far were you off? If you were guessing one, how far were you off? We also don't know, okay, did that make you slow? But we can kind of tell, hey, well, an estimate of one seems like it's definitely not right here. Well, how do I know how not right it was? The easiest way, sometimes, is to generate an actual plan yourself. I can take that value that cutoff date was compiled for. I can say, okay, you compiled for this value, and I can run the stored procedure with that cutoff date. Sometimes. This varies by environment, right? Are you allowed to run this against the production server? Well, sometimes absolutely not in any environment because it might be a stored procedure that changes and modifies a bunch of data. It might not be safe to rerun. Even if it doesn't change data, in many environments, you're just not allowed to rerun stuff for testing against production. If you can restore a copy of the database to another server with the similar data set, you can run against that. Or if you're allowed to run some queries, I could, write a custom query saying, okay, I'm going to write a simple query to count the rows in this table after this modification date. I'm going to have to be really careful if this is a very performance sensitive environment that query doesn't cause a problem, right? So I need to have some way to figure out how far were you off, but I've got to be really careful, and the rules and processes vary. For the sake of simplicity, this is a procedure that only runs a select, and let's say that it is safe to run in this environment for my job role, because essentially what I'm doing is running a stored procedure that is commonly run by our application, for instance. So I am going to turn on actual plans in my SQL Server, which you can do by hitting Control-M or using the little connected squares button at the top of Management Studio, and run the procedure for the same parameter value that it was compiled for. Now my execution plan has a very similar shape, but the line widths are different. And when I hover over that very same line in the execution plan, I can see estimated number of rows is 1, actual number of rows is 12,000. So it was, we have been doing some business in 2017 and it was off. So I can now see that, okay, we did have an issue where we underestimated this. But there's an important thing to not miss here. When I am doing this, if I'm running the query for the parameters it was compiled for, is the query actually slow? Now this might seem obvious to check, but I have forgotten to make this mental step before. It is actually a step worth taking. When the query runs, even if statistics are off, is it actually slow? If I measure the duration of my query, and I'm going to turn off my execution plans, and I'm going to use set statistics IO and time on. I'm going to use this command to say, for my session, go ahead and put in the Messages tab information about how many logical reads I did, how much CPU I burned, how long I took. Even with this underestimation in stats, the elapsed time for my query is 170 milliseconds. Yeah, the stats are off, but sometimes even this off, 12,000, it's not that bad. My performance is still good. So if people are reporting that this query is slow, this is a tricky situation to unwind because you've got to say, okay, well, maybe I suspect it's a stats issue. If I'm going to inspect that, even if the stats are off, don't assume that the query is slow if the stats are off, because sometimes even just being within a very large ballpark range can still get you fast performance. It may be that this query, I'm not saying that the query wasn't slow before. It may be that, yeah, the stats are off, but when it was slow before, maybe it was being blocked by someone else. Maybe there was a completely different set of things going on and it wasn't related to the stats. This is tough because stats can be kind of a giant red herring. Sometimes they are the issue, but we need to measure all of these things because sometimes even, kind of close, not really close stats are actually good enough to give fast performance. There is another thing to think about as well. This query is fast when I run it for the cutoff date, January 1st, 2017. Sometimes we have an issue where the query in cache, the execution plan in cache, the values it was compiled for, it is fast for those values. But when someone comes back and runs the code again, but with different values for those parameters, and it reuses the plan in cache, it's slow because reusing the plan for different parameter values doesn't always work. That's not the fault of the statistics if you think about it. Statistics are being used to optimize the parameter values at the first compile. When the plan is reused, it isn't even looking at the statistics. If you happen to go and update the statistics manually, if you're like, I suspect it's the stats, I'm going to manually update the stats, that, even if the stats, were fine for the original compile, what can happen is your manual update of the stats causes the next run of the query to have a fresh compile because the stats got updated. And maybe the next compile is for different parameter values and maybe these reuse better. So then You think the problem was that the stats are bad because you updated stats and it seemed to fix it. But really, the issue was there was a plan in cache that didn't get reused well. And your update of the stats just really threw it out of the cache. So it's worth taking these steps, although they are cumbersome, and although, figuring out all this stuff, especially if you're not allowed to query production, is very time consuming. It is worth taking these steps so that you don't misdiagnose the whole situation and then end up in a case where you're always updating stats and you're like, why does this keep coming back, right? If you need to inspect your statistics, you can query SQL Server and look at a dynamic management function named sys.dmdb stats properties. This was introduced in SQL Server 2008 R2, I believe. And it can join to the sys.stats table. I have a query where you can essentially put in the name of the table you want to look at and say, I want to see all of the stats on this table, and I want to see the statistics that are associated with indexes as well as the column statistics. We can see, was the statistic automatically created? When you create an index, it automatically gets stats associated with it. It will still show as 0 in that case. Column statistics that are automatically created will show as auto-created. You might have someone who wants manually created stats. There's other ways stats can get created too. You can see the columns associated with the statistic if there's a filter, the date that they were last updated, and then a modification counter, which is an estimate of how many changes look like they've happened in this statistic since the last time they were updated. We can also see the number of rows in the table at the time the statistic was updated, and then if a sampling was done, how many rows SQL Server sampled when it updated that stat. So for my last edited when column, I can see that it was last updated at 432. The modification counter is at 12,000, and that is exactly the number of rows that I messed with in the table, and that at the time stats were updated, it had 70,510 rows, and it had sampled 13,545 of those. So I can get a lot of detailed information about when these statistics were updated if I do want to know, like, oh, well, maybe they haven't been updated in weeks. Well, I can tell, and then I can also get an estimate of, okay, has much really changed since then? Because perhaps we aren't making any sales and our invoices table really hasn't changed, in which case we have other problems to address. If you do find that, yeah, the statistics were way off, and they were making the query slow, there's a couple things you can do to treat this. You can make your index maintenance smarter. In the case of our original question, when they had just offline rebuilds running, all of the statistics associated with their indexes were getting updated. So they could look at and evaluate free scripts online that say, hey, okay, if I'm doing a reorganize, I am going to go ahead and update stats. And then also may have bells and whistles to say whether or not you want to just skip the stats update if it looks like no rows have changed in that modification counter too. You could also look at when you do data loads and make them smarter. Do you do an incremental load where you churn a bunch of data in some tables? If so, at the end of that data load, you might want to have the data load update statistics for sensitive columns that are queried afterward, so that after I change a bunch of data, I make sure I have fresh statistics there so that those are faster. You could also consider changing the threshold at which statistics auto-update. In SQL Server 2016, if you're at compat level 130, you'll use a new and improved algorithm that doesn't just go with that flat 20% approximately threshold. It's smarter, and the more rows you have in the table, it dynamically changes the threshold to update statistics at a more frequent amount based on the data you change. In lower versions of SQL Server, but it have to be 2008, R2, SP1, and later, you can turn on the same feature with trace flag 2371, so you could make your statistics auto-update more frequently. You could also test out the new cardinality estimator. You could test it out with the demo script. So one of the great thing about the gist that I'll post along with this is with 2016, you could totally see how flipping these on changed the query plan and the row estimates in the sample query. They have fixed some classic estimation problems in the new cardinality estimator. That was introduced in SQL Server 2014, and in 2014, it's controlled by database compatibility level and trace flags. In 2016, we have new database level scope options, as well as of Service Pack 1, a new query hint that we can use with a new improved low permission syntax to control this. You could also make your query less sensitive to statistics. Sometimes we have queries that are just super sensitive, and occasionally they get a bad plan. And sometimes it's due to statistics, sometimes it's that they get compiled for specific values that maybe use statistics in a way that gets a plan that just isn't great for the SQL Server. I'm not sure who to blame in this situation. Do we blame the parameter values? Do we blame the statistics? Blame is time consuming. But sometimes we just want to say, I know what plan I want you to have. I don't care like what parameter values you're compiled for. I don't care what the statistics say. I want you to do this specific behavior. Well, there's a couple ways you can get there. Sometimes you can craft and change the indexes on the table so that there's just this obvious perfect way to run the query. No matter what parameter values are passed in, it's like, oh, duh, well, this is obviously I have this perfect index or, perfect setup. So sometimes you can get a stable, high-performing plan just with index changes. Other times, if you can't do that, you can use hints in the query, or you can use tricks like freezing the execution plan in Query Store in 2016 to stabilize that execution plan and say, I want you to do this. Now, there's obviously risks when it comes to pushing around the SQL Server optimizer and saying, hey, I know best. If you're right, this works out really well. If you're not right forever, then later on you might hit a regression again, and then people are like, why did you put that hint on that query? So there's pros and cons to this. If you do things like hint your queries or freeze your plans, you want to keep track of those. And I've got a whole course that I'm putting on SQLworkbooks.com about this exact subject of how to be a bad kid and push around the SQL Server optimizer and get away with it, right? If the statistics are okay, if you go through all these steps and you look at the stats and you're like, no, the statistics were good for the values that the query compiled for. In that case, where to look next is to say, all right, so is the issue that plan is being reused with different values? In that case, I need to figure out what are other commonly used values with this procedure so that what I need to do is get that plan in cache and then reuse that plan when running the procedure for other values. It can be tricky to track down what those other parameter values are and what's running when it's slow, but you've at least got the compiled for values, which is maybe about 60% of the battle. Like it's extra legwork, but on the other hand, it's also job security. So thanks so much for this great question. I obviously enjoyed it. We've had 2 episodes on this on Dear SQL DBA. If listening to this has inspired you with a question of your own, or you just have a question about something else, hit me up at SQLworkbooks.com/ask. While you're at SQL Workbooks, go ahead and sign up for a free course. I've got tips on using Management Studio, got how to troubleshoot blocking. We've got lots of good stuff. And that course on bullying execution plans is coming soon. Thanks a lot. I'll see you next week. I'm Kendra Little from SQL Workbooks.